This episode of Troxel is supported by Avail. Content is more than Revit families. If it's digital, Avail can handle it. Learn more at getavail.com. Welcome to the Troxel Podcast. I'm Evan Troxel. This is the podcast where I have conversations with guests from the architectural community and beyond to talk about the coevolution of architecture and technology. In this episode, I welcome Platt Boyd. Platt is the founder and CEO of Branch Technology, which is located in Chattanooga, Tennessee. Branch Technology has combined novel 3D printing technology, conventional construction materials, and large-scale robotics to create buildings that bridge the divide between the past and the future of construction. They are currently focused on fabricating freeform 3D printed building facades. In this episode, we discuss how Branch Technology began, their purpose as a company, working with robots, cellular fabrication, parametric design, and design freedom, their cross-disciplinary team, innovation through collaboration, stewardship, leadership and core values, focus, what's next, and more. This is a great conversation because they're actually making real stuff. And what I mean by that is they're going beyond software. So it's a really cool combination of hardware and software and output. So without further ado, I bring you my conversation with Platt Boyd. Platt, welcome to the podcast. It's great to see you again.
Good to see you as well.
And we met in Chicago. We met at the Auburn alumni get-together. And then on the show floor, we were both exhibiting in our various booths. But your booth was very impressive. But even before I saw the booth, meeting you and just talking about what you're doing, it was like, I got to talk to this guy on the podcast because I want to share this with everybody. Because you're basically making it possible for paper architects to be legitimate. It's amazing the work that you're doing.
I appreciate it very much.
Well, take us through this story. I want just to get to the point where you're introducing Branch Technology, but Platt, how did you get to where you are now? Because it's got to be an interesting journey.
Well, I'm a normal architect and used to practice and had been in the firm for 15 years, and I was a partner there, and that's what I thought was going to be my retirement. And then had this idea about how you could use 3D printing as a scaffold for normal construction materials, and just had a sketch. Really, I was working too late on a Saturday afternoon and went home and talked to my wife, and I said, I think this idea could be significant. And it was upsetting. Like I realized that if this works, then
you had to do it.
It's a big deal.
Yeah.
So anyways, that's where it started, was just a sketch, and then spent 9 months, nights and weekends, investigating like patents and robots and polymers and like investment and all this kind of stuff. And it was it was my passion. I still have the day job, but it was investigating it nights and weekends for 9 months before taking that leap. Because I've got 4 kids, and that's a big deal.
It's a significant risk, right? Yeah, I think we talked about that in person, and it was like, I remember you saying that. Like, when you see it, and when I see you say that face to face, I can still see kind of the existential angst that was involved in that decision.
Yeah. So anyways, we knew that we could take it forward for like a certain number of months on savings, and then maybe a little bit longer on 401k, but then it had to work basically. So, and started having investor conversations, and then started prototyping in the early days, and pitched the CEO of Kuko Robotics to give us a robot in the early days, just to experiment with. And he went along with it and gave us a robot for, well, it was supposed to be 3 months, turned into 15 months. And anyways, it started working. So that was the early days.
And how long ago was that? I mean, you say early days, but give us a time frame.
That was 8 years ago.
Okay. This is an instant overnight 8-year long story.
Yeah, exactly. Definitely the hardest journey I've ever been on, but also one of the most rewarding is just to see what people are now coming up with based on our capabilities and enabling them to be more creative and realize something that has for years only been digital, and enabling that translation from I can create this and I can 3D model it. Now I can actually get it built in more normal construction budgets. And so that is amazingly fulfilling to see that purpose, the original purpose of why it was started is to democratize design freedom and allow that architect level design freedom into more normal construction budgets. That's one of the purposes behind what we're doing.
Okay, so I think so far we've been a little bit opaque. You mentioned 3D printing, you mentioned scaffolding. I think when people think of 3D printing, they kind of automatically think of scaffolding anyway. So you're talking about a different scaffolding. And we talked a little bit before hitting record that this was going to be a podcast, a subject that suffers because this is not a visual podcast. And so we're going to do our best to paint this picture. So explain what branch technology is and the kinds of things that you're doing.
Okay. So big picture, we make facades for commercial buildings. And we do that by prefabricating parts in our facility. And it's using construction scale 3D printing and big robots to make those walls. And the way that we do that is a method called freeform extrusion, and where that material that we 3D print with, it extrudes out of a nozzle and it solidifies almost immediately upon coming out of the nozzle. And so we sequence that robot to create a cellular framework. We call it the matrix, and it is a true matrix in that it has coordinates in X, Y, and Z directions. And so just imagine a series of cubes stacked upon one another, and the robot traces a path that goes along the perimeter of each of those cubes and creates this cellular matrix. So it's a series of grids and that are structural, and then we take the voids in those cubes and fill them with other materials. And so we use a polyurethane foam that's fire rated to infill that matrix to make a composite. And that's providing the insulation value. And then we put a finish on top of that. So the finishes that we put on top of that composite structure are either glass fiber reinforced concrete, a 3/4 inch layer of GFRC, or the lightweight stuccos that are kind of troweled on as systems. So the interesting thing about it is that matrix, and we call the method cellular fabrication. But that cellular matrix is something that a 2-pound piece of this, the size of a concrete block, can support 3,000 pounds in compression. But once you fill it with the foam, it more than doubles that strength. And so it reinforces each of the struts and prevents them from buckling. And now that same block could support 6,000 to 10,000 pounds, depending on the density of those cells. And so that's about 3 to 4 times the strength of normal wall framing methods.
Wow.
So it can be structural, but for what we're typically doing as a rain screen, it's just supporting its self-weight and the lateral loads that are imposed on the facade.
Like drift between panels?
Drift or wind load primarily.
Okay. Interesting. And just to give people a little bit of a further vision of what this is, when you talk about the nozzle and this material coming out of the nozzle and drying as basically as fast as it's coming out into the position that it's in, that's two things. You don't need to build layers up like traditional 3D printing. And the other thing is like the nozzle is way bigger than a traditional 3D printer, right? You were talking like, what is it, like a 1/4 inch or something like that? Or
Yeah. It's about 1/4 of an inch. The extrudate that comes out is about 1/4 of an inch, and that's what gives it its structural properties. Because like something that's as big as the little filament extruders, that wouldn't support load.
right. And when you build the cellular matrix, give an idea of the scale of the cells. You mentioned cubes, but like the scale of the cells themselves and how they're, I mean, basically you're turning every shape into a mini space frame that is structural in every direction, I would imagine.
You got it. And we can vary the size of the cells, but typically we're at 2 inches between the height and width and length of each of the cells. And then those are all braced as well, cross-braced, so that they become a structural lattice. We can do bigger or smaller. When you start getting bigger, it gets a bit more floppy. You get smaller and it gets much stronger, but it takes much longer to print. And so we've kind of optimized to an average of speed and strength at 2-inch cubes.
And is there another constraint here, just the material that you're injecting or pouring into this, as far as like I would imagine there's an optimized ratio of cell structure to the void form that you're filling it with to just get an adhesion between those two to act as a single unit.
Yeah, and we've kind of worked with this 2-inch optimum for a while now, and that's what we've done. One of the things that we have to do is characterize everything and go through all kinds of testing in order to say this product meets commercial building code. So we've spent years of time, millions of dollars in testing all of these products to be certified to commercial building code. And so as you start modifying any of these big variables, then you have to retest everything.
So you're trying to avoid that to some extent as well.
To some extent, yes.
It's a big deal.
And so we've got an assembly, and so what we make, I forgot to talk about that. What we make are range screens, either like a range screen that hangs on a traditional carriage system, or we also do a mega panel. And the range screen, the panel sizes for that can be up to 4 feet by 10 feet. And then the mega panel is in association with the national network of prefabricators. And those panel sizes can go up to 10 to 12 feet wide by 30 to 45 feet long. And they can be oriented either vertically or horizontally. And so our product in that regard is the insulation and the articulation on the outside of a light gauge metal frame. It is the structure for those mega panels.
And that's basically those sizes, at least at the larger size, are determined by logistics, like the Department of Transportation, things like that.
Correct. What'll fit on the back of a tractor trailer.
Yeah. Okay. Because your facility, if you're doing the rain screen panels, you're doing those in Tennessee, and then these other ones you're working with a network to kind of get closer to, or maybe based on special requirements of a fabrication facility to get those panels built and logistically close to a project potentially?
Sure. So we ship product all over the U.S. and we've shipped products to Japan and Saudi Arabia thus far in the world. But we can ship from here to wherever. The panel sizes for the rain screen, we do all that here. When we're doing the mega panels, we send our what we call composite core, which is the printed, foamed, and milled down robotically to whatever the articulation project is for the facade. We ship that out that's unfinished to our partners. They apply that onto the walls and then they finish it. And then they ship it and install it on the job site. So that's kind of the two different methods that we use.
Okay, now let's attempt to paint a picture of what it looks like. Like, what are the kinds of forms that people are building? Because I think we're implying complex curving surfaces, things like that nature. But really, I think it would we'd benefit from you giving us some examples of the kinds of forms that you're creating as exterior rain screen or mega panel installations.
Sure. So it basically is up to the designer and to envision what they want their facade to look like. So it can be almost any pattern. Every panel can be custom. So we have a depth to play with for that embossing that is anywhere from 8 to 12 inches depth. And so you can create all kinds of patterns. You can create imagery. You could create whatever it is you want to be that theme for that building or the branding. So that's kind of you can do almost anything. And what's really neat is if you understand parametric design and like what's possible in Grasshopper or CATIA or Dynamo, that enables inherent complexity. And that complexity is very difficult to realize with traditional methods of construction or materials. But this enables that complexity to be illustrated onto a building in different patterns, scales. And so it's really creative freedom. I mean, that's what it is. So I'm trying to think of a good analogy of it.
I think what's interesting is you've got like you said it a minute ago, multiple scales of patterns. And I think one thing that I would just throw in here as a designer and thinking about this is I see the panels that you're creating, and the panel itself could kind of be thought of as a base pattern. And then what you're saying is you have this additional thickness on the surface of that to do even more with custom patterning on top. So it's like you can have a macro pattern. Like I'm thinking of like a Zaha building or like the Peterson Museum in LA, where it's these big swooping things. I know that's metal panel, but just one of the types of facades that comes to mind, or maybe even Disney Concert Hall or something like that, something that Frank Gehry would do, where it's this large scale panel that has a superstructure frame holding it up. But then on top of that, you could further articulate additional patterning using shade and shadow and depth and, all of these things with your tooling as you're building each panel to that the combination possibilities here are truly endless.
Yeah. Understanding, well, the structure behind what we make can be simplified and segmented, and then we can still create curvature on like a large scale. You can also look at kind of creating patterns that are individual on each panel, or create a macro pattern across multiple panels. And so it really enables just a level of articulation that's unprecedented and unavailable with traditional methods manufacturing. And so we create that using milling, like robotic milling. So when you give instruction to a robot, it will follow whatever contours. So one of the projects that we did that's under construction right now, we're finished with our part. It's in the installer's hands right now, but was a LiDAR scan of the moon. So it had 6 billion points, a point cloud. So we didn't need that much information. It was about 4,400 square feet, but we put the surface of the moon on those panels. And so the topography of the moon, we set the depth of that articulation to 8 inches. And so you can read the topography of the moon across all those panels. I did one preview image on my LinkedIn a couple weeks ago, and you can see that level of articulation that's available.
I'll put a link to that post in the show notes and obviously to your website so people can see additional examples. How did you talked a little bit about how you started to go down this rabbit hole, but what was your experience before this with complex facades? Was there any, was this a total jumping off point that was totally tangent to what you were already doing as an architect, or
this was a
complete
departure?
Okay, a complete departure.
I worked at a very traditional firm. This was in Montgomery, Alabama, and I did a lot of white columned buildings as part of the state capitol complex, and so very, very traditional. So this is a very big departure from that. And now collaborating with some of these most advanced firms in the world, looking at how they're using these tools to create the next generation of architecture.
And they're really just the first ones, right? Those are the ones who are like, they're already have some foot in the door on the tech to do this. But what you talked about this early on was democratizing this, right? Because I think what a lot of people do is when they see that stuff, they're like, oh, my firm won't do that. But what you're saying is like the tech is actually here. It's in tools that you probably already use, like Rhino and Grasshopper, to, yeah, you can do this too, right? That to me is what's really, really interesting about the work that you're doing as a product manufacturer. And so this is another big departure, right? You went from architecture to product manufacturer to fulfill the vision of our other architects.
Correct. Yeah. And it's been a huge learning curve. And so, like me as an architect, I'm having to learn a ton about manufacturing, quality control, software, hardware, robotics, material science. Like these are things that we now have a team of experts. And so it's relying on that expertise that's outside of the realm of architecture, but these people know how to deal with like quality control in the manufacturing environment, or how to control robotics to do custom things every single time, how to create software that will analyze or vet geometries. That's one of the things I'm most proud of is the team that we've got here that incredibly cross-disciplinary, that collaborates to create solutions that are not just kludged together, but we have a core value called design beauty that's meant to be, you look at complexity, you look at systems that are available, and then you reduce that to elegant simplicity, so that you've got integrated solutions rather than just things that are cobbled together that look ugly. So that's one of the our core values is that we try to have integrated solutions that provide form, function, ability to do things quickly and easily within the products that we're creating.
You sound like an architect right there, because these are like guiding principles of a project or a firm or a design studio. What are the other kinds of core principles that you're operating under?
So that's one of them. That's often the outcome of intense collaboration. That's one of our core values is like you draw in expertise as needed to solve the problems, have everybody around the table come up with that solution. We've got, from a people standpoint, humble genius is one of them. It's working with people that you enjoy working with. They do brilliant work, but don't think of themselves as genius. And we've got a strict no asshole policy because you want to enjoy the people that you work with on a daily basis. And so that's something that is a good thing.
I love it. More firms in the industry need that policy. We all know it.
Wise stewardship is another. It's like we're given this like opportunity to bring this into the world, and we have finite time, finite resources. We're often the fiduciary of other people's funds on a project and from an investment standpoint. And so it's being a steward of that, and then the materials. Like one of the things that's inherent to 3D printing is that you're only using the material necessary to create a geometry, and so you're reducing the amount of waste in the construction industry. And so that's, and we try to do that through like efficient factory operations. And so there's a lot of stewardship of resources with what we're making. So I don't know. I love our core values, and there's more if you want me to keep talking about that.
Well, those are fantastic. One of the things that I was thinking about as you were talking about those was that there's a lot of firms that just do what they've always been doing. And I think through that process, you start to lose the tight-knittedness of what core values are and what they mean. How do you keep those kind of top of mind? How do you keep those active in the culture? You've been doing this for 8 years now. Maybe you have had some of those the whole time. Maybe you've had all of them the whole time. How do you Like, I think one of the most useless ways is to write it really big on a wall. But so hopefully I didn't just, offend you because you've got it written in the factory on the wall. But it's like, what are the ways you actually get those things through
We
the
did
culture?
that too.
Yeah.
But no, the main things is you hire and fire based on those values. And then like on a quarterly and annual basis, the reviews that we do, the feedback loops for how we kind of work together, we use that to do the reviews and kind of how is somebody embodying all these, and we've got 6 core values. And then once a year at least, I'm giving kind of a hour-long talk, kind of saying, here is what we're talking about. And not just a one-pager, these are the values, but here's the elaboration of how this works out in practice. Here's some examples. We've got Slack, and so we use that as something that will highlight examples of, oh, this person did this as a great example of relentless execution or wise stewardship. And so you keep them at top of mind. It's not something just written on a wall. It's got to be something that's daily part of the vocabulary and part of like how we operate. With our leadership team this morning, we were doing an exercise, and I brought up 2 things that, like, if we don't keep this in top of mind, it'll start slipping. And this has to do with these 2 core values, and like we need to make sure that's we're the examples of this for the company. So
how did you get to the point, or how did you start with this? Did that come from previous practice, or you saw a lack of it, or you just desired to run a company this way? Like I could see the answer going a bunch of different ways, but then, well, start there. Where did this come from?
Okay, well, that's a big question. It gets into the DNA of how we, like, why do we do what we do? And we went, I think, 5 levels deep asking that same question to get to what is our core purpose first.
Mm-hmm.
And what that has to do with, and then kind of codifying how do we operate, not aspirationally, but how do we really do things? And then let's hold ourselves accountable to that. If we start slipping, like, we need to be constantly reminded of these things that we hold dear, and the why those are dear. And so we went through a process about 3 to 4 years ago to codify them and to come up with 2-word descriptors. It's not just courage or like strength or whatever that can be very, very ambiguous. It was like, okay, these 2 words together are appropriate descriptors.
Let's take a quick break to share more about our sponsors. You've already heard a lot about Avail as a longtime sponsor of the show, but wait, this is a new message for you, distinguished listener of the Troxel podcast. We can't talk about Avail's latest desktop release without talking dynamic paths. You know what I'm talking about. Yeah, of course you do. Dynamic paths allow BIM managers to store data in BIM 360, OneDrive, or any other cloud solution. In the latest version of Avail, they expand on location agnostic, making content easier and faster to find for the user. Imagine not having to worry if the content is on a local network drive or in the gazillion cloud storage locations. How is this even possible? Pure magic. It's the stuff of unicorns and rainbows, my friends. Let's keep this just between you and me. Here's some of the details. Following on the promise of being content agnostic, Avail now makes location complexity a thing of the past. Content is more than Revit. It ranges from Rhino to AutoCAD to Office documents. Well, this is next level. We're talking network locations. Have you ever seen one location where all the project content lives? Snap out of it. Of course you haven't. Content can live anywhere, from the local network to BIM 360 to OneDrive to any other cloud location. Why does this matter? Well, good thing there are no dumb questions. Because the answer is that it frees up users to concentrate on design, which pays the bills, and getting content into a project, not managing technical issues around network drives and paths. Let's face it, they aren't that good at that anyway. Avail's mission is to make finding content simpler and easier. Like our favorite architect Louis Kahn once asked, Data, where do you want to live? I don't think he really asked that question, but Avail allows teams to, so let's just roll with it. And hold the phone. For those of you who know what this means, Avail also supports federated data requirements. Data can live where it needs and must live, allowing users secure and simple access to it. So, what's the takeaway? What's the big picture here? Settle down, I have it right here. Avail is a platform that connects all types of data from all types of locations, hiding complexity. Try it today. Go to getavail.com to learn more. And now let's get back to our conversation. My next question is leading to, okay, so what have been the outcomes of that in your culture? And I assume that they stay alive and they get talked about a lot and they're top of mind because you see beneficial outcomes. So that has to lead somewhere, right? Having these things written down, having them top of mind, bringing them up in reviews and making them the framework for reviews. There has to be beneficial outcomes to that you see. Is it morale? Is it the culture? Like, what are those things? Because I think a lot of companies go through setting those things up and it's like, okay, check. We did the mission. We did the values. We're just going to keep working now, right? And so the integration that you continue to push of those values into the culture means something. There's a reason why those are they're still there.
Yeah, we do internal kind of what's called Net Promoter Score surveys, and as we do those, they say the two things that are consistently coming back every quarter when we do those is like, what are the most things that you value the most about the company? And they'll say the people and the culture, very, very consistently. And so that's a huge benefit, and because if you got a place that people enjoy working and it's with people that you enjoy working with, that trumps strategy all day long and technology or whatever. Because, and I've seen it over time, we are a startup and we've had to kind of adjust and pivot and move in different places, and we've been through ups and downs. But as you have that culture, you can adapt. If you got the right people with the right attitude, you can do almost anything. And so that's a huge value. And we've had to go through some really, really crappy stuff at times. And then you got these amazing things also. So like the team, how they adapt, and they see the benefit of it.
Yeah, it's I never expected this podcast to really be about leadership. We definitely have kind of pivoted from tech and the amazing stuff that you're doing to leadership. But I think that this is something that's an important topic in the community that I have for the audience of this show, because I mean, there's no shortage of toxic workplaces in the profession of architecture. There's no shortage of toxic educational practices and things like that as well. And one of the sayings in my day job is, as it starts, so it goes. And if employees are showing up to work at a place like Branch and there's a set of kind of baseline expectations in the way the culture is, and they choose to become a part of that, right? They choose to be aligned with those values because they share those values, or they like the outcomes of those, like whatever those reasons could be, then so it goes, right? And if you're setting that expectation up front, it makes all the sense in the world to continue to talk about those things because you're getting the outcomes that you want from those, and you're designing to an extent the culture, but the people are really filling in the blanks with all of the different pieces of that culture to make it the actual company culture. Like you set up the framework, the scaffolding. Like we keep coming back to scaffolding on so many scales here, but then they're filling in the rest of that, and that's how you've created such an amazing team.
So, and that's one of the things that I think will be our biggest challenge moving forward is as we grow, maintain that same spirit. I I've never done this before, and so like trying to keep those values is going to be a challenge.
Yeah. Well, let's get back to the tech and the delivery side of this. I mean, a couple threads are interesting to me. Maybe I'll put them both out there, and then you pick which direction you want to go. The first one is like it takes a lot of money to start up a manufacturing business, and that's very different than architecture. Like you can set up an architecture shop tonight, right? You can quote unquote hang your shingle. So that's one like maybe potential topic here. The other one is just how do people actually get into this process that you help them fulfill? So there's like a tech side of what are people designing in, what do you intake, then what do you do with it until it finally gets to the put in place on a project. So two very different topics, and I don't really care which direction we go because I think they're both interesting. I just because of time, we don't even have to go down both. But I think if you want to pick one of those and run with it, let's do it.
Okay. Well, I'll say this, and then I'm going to move into the second topic.
Okay, so we are hitting both. Okay, excellent.
The investor side of things is the steepest learning curve of anything. And we've had to raise money over the years, and $22 million to date, and through different rounds of funding. And that's definitely one of the hardest things that I've had to learn throughout this whole thing. That's a whole complete separate podcast.
Okay.
And it is very difficult in construction tech and creating something new in a very, very old traditional industry. That's something that at the beginning of this, there was zero construction tech investors. And as time has gone on, we've seen people become more and more interested in this industry because it is so inefficient and it is so huge. So there's lots of innovation that's possible there. But the second question is the more important probably to your audience. And so I'd rather focus on that, which is how to incorporate this into like projects. And so we work on a daily basis with architects, designers, contractors, developers, but most often it's with the architects. And we work with them if they've got the capabilities to design, like with our design freedom, like, and they can understand parametric design and all that kind of stuff, then we take what they give to us and run with it. We may adapt it a little bit to refine it for our capabilities, but that's the ideal, is when architects can come up with the designs that we can then make. Sometimes, though, that's not possible. And so we can go through what's called a design assist process. We've got a very, very talented design assist team here that can come up with themes, and we show, here's a couple options for that particular building based on feedback that are themes that the owner or the architect wants on that project. And we will create designs and patterns and things for that particular building. And so either of those is perfectly viable, but kind of the process of what it looks like it's a 3D model. Like we're working with whatever 3D modeling program people are comfortable with. So whether that's Revit, Rhino, CATIA, SketchUp, it doesn't really matter. And so we receive that model from the architect, and we use that as kind of the beginning point. We want the native geometry in that program, and then we put it through our kind of internal process to take the articulated surface, create an internal geometry that's the matrix, and then all the robotic code to instruct the robots how to print it, and then a second layer of robotic code for the milling robots to mill the surface geometry. And then so the model that we end up using for what we call digital production has multiple layers in it, but it starts with the outer layer that is the surface geometry. And then we build in like the intelligence, the machine code, other systems that have to be incorporated into it, like the attachment points and the spacing on a facade or onto the building, how it attaches back. We have to go through engineering, working with, we have internal structural engineers that engineer the panels that in order to meet whatever building code it is in that location. So whether that's coastal or inland, and the wind loads that are for those regions, or lateral loads if it's in earthquake zones, seismic loads if it's in earthquake zones. And then we'll produce shop drawings that go through we wish that you could have a truly digital process, and we just use that 3D model. But we're still in normal construction land, and so we have to go through the traditional shop drawing process for approval, and then that's what goes into fabrication.
I was going to ask you when do you want to get involved on a project? I think I know the answer, right? But when's the most ideal or beneficial for everybody time to get involved in a project? And then what is the contract language around design changes, cutoff dates, stuff like that?
So we can get involved at almost any stage. Oftentimes the design intent is set in an earlier stage, and like schematic and preliminary levels of design is oftentimes when we get involved in a project. We've done a couple projects, though, where it was already under construction and they had specified around a certain product, and we came in as a substitution. That happened on a couple different projects, and so which is way, way late in the contract game. But if you can people are open to that, then it's something that we can kind of go through a pretty fast iterative process and still meet the construction schedules.
Interesting. I think about like how much information you could infuse into me as a designer, knowing what the constraints or possibilities are before I even start drawing versus coming in late and having to like once I go to you and you say, well, actually that's not possible. And I know you're going to work with me to come up with some potential ways to solve that, but it kind of would have been better if I would have even known what, if any, constraints are as early as possible as a designer. So I think you're not alone. Like every building product manufacturer out there should be involved earlier because they know so much more than I will ever know about the domain that you're an expert in. And in 20 minutes over a phone call or a video chat, you could probably distill something to me that would have taken me 4 hours to find on my own on Google, right? So like those are the kinds of things where I could just see earlier is better. And if there's any possibility that the project is going to go in this direction, I should talk to you as soon as possible.
Sure. And we also have design guides that talk about criteria to stay within. So it talks about like curvature, facet sizes, depth, panel sizing, all that kind of stuff. And then we have an internal mechanism to vet for each of those criteria and give feedback on, okay, this is outside of spec, but this is everything else is fine, to give kind of visual feedback on what's possible. And so that's kind of the software side, but the design guide is something that we send out, publish, and give to designers.
I would love to include that in the show notes because I think, again, being proactive about, you never know when you're going to need this information, right? But if you review it once, maybe something will stick in your mind to just know that, okay, that information exists, number one, but also it gives somebody some boundaries to, even though you're basically saying like, whatever you can think of, we can probably do it. Like that's kind of poison for a designer, right? It's like, really, blank page? I got no constraints. I know that there are some, but it's just one of those things where you're just changing the game when it comes to what forms are possible to put on the skin of a building. And it does help to know a few of those little gotchas and to think about logistics and to think about those kinds of things.
And one of the things that we're about to launch, it's not out there yet, but it will be on the website in probably a couple months, is like a panel library. So these will be Revit families that you can download, and they can be manipulated to a certain extent. It's not the full customization like with a Grasshopper script, but these will be Revit families that you can mess with. And so what that does is it gives the capability into the designer's hands to like have a starting point. And it's a parametric family, so it has limits on it. So that should be coming out in the next couple months.
Maybe you start wrapping up here, but I think like there's a whole aspect to robotics, fabrication, where you're designing, you've mentioned it a couple times, like the code that runs the robots. Like, and so there's this whole other level of design problem that you guys are handling. Like, I don't necessarily have to worry about that. You've run it through your different automations to see if it's within spec. Once it gets to a certain point and we say, okay, like this is it, this is the final version, right? Okay, we're going to actually start building fabrication code off of this model right here. And what was it like for you to go through that design process of actually designing that code? Because I can imagine it's a bit overwhelming, totally foreign to where you came from, right? Doing white column buildings. And when you're designing that kind of stuff, I think that's something that's always interesting to me in the manufacturing process is like you get this final thing, but we really have no idea what it took to make this thing or to make even some of the parts of this thing, right? And there's a whole like designing the tool, designing the machine part of it. I think that's pretty fascinating. Can you just speak to that part of what you guys have done at Branch?
Like in the early days, like I had to learn Rhino and Grasshopper, which I had no experience with, because we used a Grasshopper plugin that was controlling the robot in the early days. But Grasshopper actually makes that accessible to an architect, which is freaking amazing. And so the tools that are now kind of becoming more commonplace allow for like even the democratization of technology to somebody that doesn't know how to code and having to learn just a little bit of that in the early days. So that was in the very, very beginning. And then somebody gave me a great piece of advice in the early days: stop hiring architects and get a real software person. When I did that, I was like, oh, you have so many more capabilities and you can solve things so much faster. And so we've had computational engineers that are like PhD level, how to create structure and how to sequence things. And this is in some regards, an NP hard problem where you're sequencing something with millions of points. And how do you do that efficiently? With our structure, it's not as difficult. But where we're going is creating more complexity and solving that in the non-structured grid manner. And so software people to do that definitely are needed. And so creating the tools and now some of the things that we're doing on like the design automation side to take, like once we get a geometry, how do we take it and make all that into parts and all the robotic code? And we're trying to automate more and more and more steps of that, and even to the point of like creating shop drawings. Like how do you automate that process that oftentimes was very, very manual? And so we're transitioning to CATIA internally because it's much, much better things like that.
Yeah, interesting. You mentioned like where things are heading, and I would love to invite you to talk about whatever you want to talk about, whatever you're willing to talk about there. But I think my question has to do with who's driving where you're going. Is it you? Is it clients? Is it a little bit of both? Like, do you see value that you can deliver, so therefore you're going to fund that and pursue that on your own and then make it available? Or is it really coming from the demand side where people are saying, man, like you keep seeing designs come in that you just can't do, and therefore you have to go in that direction? Where's that all coming from?
I'd say both and to that. It's one, kind of the vision and kind of where we think we need to go. And then second is like we get requests coming in from creative architects saying, could you do this or that? And it's just like, oh, well, actually we could, but we're trying like the internet and just people randomly coming in, they produce a whole lot of crazy. And so there's some things that we just say, no, can't do that, can't do that, can't do that. We try to stay focused on what is like the building enclosure world. And so that's what we try to, what we're staying focused on. But we're listening to the market and seeing where there's good opportunities within that. I guess one of the inherent things that we're doing is that we're making a cellular structure. You can do almost anything with a cellular structure. It's a small morphable unit geometry. You see all of nature is either some sort of a crystalline or a cellular structure at the base.
Yeah, I see images right behind you on your wall. That's all nature. Yeah, I was thinking the same thing.
And so it has almost infinite flexibility. And so that's one of the purposes in the name branch, is being able to branch into other areas over time. We're trying to stay very focused right now at an earlier stage into facades for commercial buildings, but knowing the flexibility of the tech allows us to diversify over time. And I know we're running short on time. The last thing that I want to touch on, kind of future direction thing, that's pretty exciting and is definitely not the core part of our business, but we've got a project that we're working on right now. The initial collaboration with fostering partners 4 years ago with NASA, and we won this structural material science competition called the NASA 3D Printed Habitat Challenge. That was 4 years ago. Right now, we're working on a contract to look at how might we use our method and materials to 3D print on the moon. And so it's a very collaborative process. We've got Stanford on the material science, fostering partners on the design vocabulary. But the purpose of this is to use in situ materials to the moon to 3D print with those native materials, lunar regolith, the dirt basically up on the moon, and a biological binder. So it's called a biologically bound soil composite. And it's using a protein binder that can be synthesized there, and you put that into the lunar regolith, and it creates a concrete strength material or stronger. And so this little piece right here on my desk, I mean, we've done it. It can use sand or the dirt on the moon to create this concrete strength material. And so we've been working over the past several months with fostering partners to create the demonstration. So in October, we're creating a small 2 rooms of a habitat here in Chattanooga, and for this lunar demonstration. And so NASA is looking at this, and they want to, in 5 years, send a machine up to the moon to 3D print and see if the mechanism and the materials will work. 15 years from now, they want to 3D print a habitat on the moon. So this is like, it's got material science, it's got robotics, it's got all kinds of things involved in it, but it's definitely the most science fiction thing that we're working on. But it is working. It's actually doing the thing that it was intended to do. So I'm very excited about this because we demonstrate this at the end of October here. And so we're inviting people to come in for that demonstration and tour the facility and see this thing that we've been working on with NASA to show here's how we might be able to 3D print things on the moon. And then the application is here on Earth that this is potentially a cement substitute. And it's something that as this works itself out on the material science side, the carbon footprint that you see in concrete and cement, if this can work to create that strong of a material it's a biological agent, the potential of that is incredible. So I don't know, it's a very, very exciting project, but it has terrestrial applications almost immediately.
You saw all of this coming when you started Branch.
You're right.
Yeah.
So it's been amazing to see where creative people take these capabilities. And that's why I love collaborating with designers and architects because they have taken it in directions that I could have never envisioned. And so that's something that I really, really enjoy working with architects who are very creative.
It's incredible to hear about. It's incredible to watch. I'm looking forward to watching more and more things develop out of Branch Technologies. This has been a fascinating conversation. So thanks for taking the time to spend that sharing knowledge and just your passion and the incredible team that you've built with us today. I appreciate it.
Well, thank you, Evan. My pleasure, and love to collaborate as we move forward, and just reach out and see if is a potential fit on different projects.
Yeah, great. Well, take him up on that, everybody out there in the audience. There's amazing things yet to come. So thanks. Talk to you soon.
Okay, thanks.
Thank you to Avail for their support of this podcast episode. Visit getavail.com to see their holistic approach to content management today. This show is part of the Gable Media Podcast Network. You can see all the shows at gablemedia.com. That's GABLMEDIA.com. You can help support what I'm doing here by leaving a 5-star review on Apple Podcasts to help get the word out, and of course, share it with your friends. I'd love to hear from you, so leave a comment on the website at trxl.co/podcast, where you can find every episode. You can also follow me on Twitter and Instagram and YouTube. Just search for E. Troxel. Talk to you soon.